Hi, everyone, and welcome to today's Sip and Solve. My name is Matt Schubert, and I lead the experienced commercial data sciences team in the development and deployment of our machine learning methods. Today, I'll be walking you through the best practices in machine learning for small business lending in just 15 minutes. I have my cup of hot coffee with sugar-free hazelnut creamer in front of me right now, and I hope you have something good in front of you too. Since we only have 15 minutes, let's get right into it. First area I'll be covering is machine learning and small business lending. To get started, I'll explain a little bit, just a brief overview on what machine learning is. Machine learning is a subset of artificial intelligence, including both supervised and unsupervised learning methods. Supervised learning methods include mainly classification algorithms or regression algorithms. The goal here is to try to make a prediction based off of past data on future events to occur. Another method in the machine learning family of methods is also unsupervised learning. These involve clustering algorithms, principal component analysis, and some other unsupervised techniques to identify relationships in the data without necessarily an event or target in mind. Today, the primary focus will be on our supervised methods, including classification algorithms. There are many obstacles that you encounter during a machine learning development process. One thing we run into, and really I think for small business lenders in particular, is the lack of interpretability, and also maybe a lack of transparency and the concern that the models and outputs may not be explainable. There's also the concern that these advanced techniques can be difficult to implement. Here at Experian, we see the opportunity to break down the black box that exists for many of these methods, and to make them interpretable, explainable, and as transparent as possible for not only the internal compliance groups, but also the external regulatory agencies that exist. We also have tackled the concerns around the difficulty to implement, which can be an obstacle for many small business lenders as well. So when considering machine learning techniques, there's really multiple approaches and different methods that can be used. But I think the overall top of the house view is to consider whether a continuous machine learning based model or a static machine learning based model is a better approach. We see continuous machine learning based models in our everyday lives. The marketing we get from different companies to select the next best offer to say, hey, you looked at this in the last time you're in, or base it off what we've looked at in our cart previously and maybe on Amazon or a different company, and then comparing that to say, okay, well, maybe you're in the market for another similar product. Here's a list of other things to consider. A lot of those are considered continuous learning models. There's also an opportunity to use a static machine learned model versus a continuous learning model. Now, there are benefits to doing continuous learning. Obviously, limited degradation due to the fact that the model is going to be able to continue to keep learning off new data without requiring a redevelopment or redeployment effort. The one concern you can have is there will be a lack of stable outputs to consider, which makes it difficult to maintain governance and also ensure you have the right governance controls in place to meet model risk management standards. The majority of small business lenders do require some level of control and governance to be involved in the process. That's where static learned models can be an option for small business lenders. A nice benefit of a static learned model using machine learning techniques is stable outputs for consistent outputs to consider for regulatory compliance. Also, you can have improved governance controls to be able to have in place to say, for example, adverse actions. You can have consistent outputs to be able to create your adverse actions and know you're going to have the same adverse actions on the same type of input data next time around. We also see some issues that can exist, though. Degradation is likely to occur. There are methods that can be applied, monotonicity and other factors to help reduce some of the degradation over time. But obviously, there will be a point, just like with any deployed model, that redevelopment and redeployment will have to occur. And with a static learned model, there is a little bit longer cycle to that. What we see here at Experian is in a regulatory focused area, static learned models seem to be a better fit for those type of purposes. So there's also a variety of supervised classification methods to be considered. There are a few others out there. These are ones that Experian has looked at heavily over the last few years. Support vector machines is one of the first ones. What we see with support vector machines is they may have great use with high dimensional data, but we've seen it's not necessarily the best approach when working with credit-related data. We also see that they're sometimes helpful in identifying the optimal parameters that we apply for other methods, particularly some of the tree-based methods. If you want to use hyperparameter tuning, support vector machines can help with that process as well. Neural networks have been around forever, rarely applied in the credit space, but often they will pop up here and there. One concern with neural networks is the lack of interpretability of the hidden layers and hidden nodes. You can make controls around the hidden attributes and making sure no hidden attributes are created or hidden variables. Yet those hidden layers and hidden nodes can still be doing some calculations or computations that may not be fully explainable. We see neural networks as being a little bit more of a black box approach, almost like trying to break open the human brain and read somebody's mind on a day-to-day basis. It may change, and unless we all become telepathic, we're having a really difficult time being able to read their mind day to day. Random forest or a tree-based method. We see random forest as being a great opportunity in spaces like fraud, especially when you're working with maybe sparse, limited data. We also see opportunity in maybe working with a thin file population if you want to do maybe an ensemble model approach or multiple varying model approach. So we do see an opportunity for some of those. Gradient boosted trees is another tree-based method. It's been heavily evaluated across Experian. We see this as being one of the most beneficial ones. Gradient boosted trees are great with imbalanced, sparse, and high dimensional data. So a common data types that we see within a credit risk analytics space. They also, since they work on a variety of data types, they're also able to be made explainable at various levels. We're able to break it down, deconstruct some of those trees, which I'll talk a little bit more about decision trees in just a few minutes. We see tree-based methods having that opportunity to provide a solid foundation with monotonicity and force to be able to provide stable and accurate adverse actions. Beyond the current approach that are used commonly with logistic regressions to create adverse action codes and adverse action reasons can be applied to a tree-based method very, I should say simply, but in a very compute-intensive and heavy type of environment, which I'll get into a little bit later as well. We see that random forest and gradient boost trees are probably the best machine learning methods for small business lending use cases due to the explainability, regulatory compliance that they can provide, and the calculation isn't too labor-intensive for most modernized systems to be able to handle. So a little bit more about tree-based methods. Tree-based methods have decision tree roots. Decision trees are fairly simple to understand, been around for 30 plus, maybe even 40 plus years within the lending industry. We see, you can look at the visual here, it's a very simplified example. I think my 18-month-old daughter would be able to grasp this fairly quickly. She's able to fit the star-shaped block into the star-shaped hole and the square-shaped block in the square-shaped hole. Now, she may not understand what a derogatory is or a DPD for days past due or inquiry, but she would understand the basics of how it's constructed and what's working, and that to get to the blue box, you need to have the certain filters to get there. Decision tree is easy to implement, limited regulatory scrutiny, provide a good, solid explanatory foundation for other advanced methods. So that leads me into gradient boosted trees. This is one of the primary methods we see of value here at Experian, particularly in business information services. We see there's improved predictive power through this series of corrective series of shallow decision trees. It's more of an iterative process, which is why we're using arrows instead of plus signs here, just to make that clear in the example that's here. This example is a boosting example to show how each tree continues to learn off the previous tree and make improvements along the way and make additions as well to get to that final score output that's going to be created. We see there's an opportunity for superior performance with traditional credit risk modeling methods, meaning logistic regression. We see a significant amount of boost, anywhere from that's the lowest I think I've seen in our current model development cycle has been around 6.5%, and I've seen it as high as 12%. I've seen some client validations with our machine learning models have very significant lift over logistic regression, and even in the 30 to 40% lift range over traditional methods. That can equate to a large volume of dollars for an organization. One thing I mentioned earlier is the enforcement of monotonicity, making sure that's enforced to make sure the outputs are explainable from an adverse action standpoint as well. Now, I don't expect my 18-month-old daughter to be able to jump in and do boosting quite yet, but I do expect her to be able to graduate from the star-shaped block and the star-shaped hole to maybe a more advanced method. Maybe it's a simple arithmetic. Not to say this is simple arithmetic, but these can be broken down into components to tie back. Obviously, gradient descent is something we have to be able to make a little bit more explainable, and that's definitely possible by deconstructing all the code that's been created for the final score. So machine learning and small business lending applications, we see a great opportunity in plenty of applications across the small business lending space. Mainly the ones listed here: origination, marketing, fraud, portfolio management, optimization, collection, recovery, all cover a great range of opportunities to apply machine learning techniques. Experian across the entire company has machine learning methods that support all these different areas. So when we move on from just the techniques, the preferred techniques, tree-based methods are the most explainable, easier to understand, easier to implement, also give superior lift to other methods. The next step is implementation. So how do you implement machine learning? There's often some barriers to deployment. One of the common factors out there across especially within the U.S. market, is the aging infrastructures. Many small business lenders have been around for a significant number of years, or through mergers and acquisitions, legacy systems have been kept longer than maybe they should have. That aging infrastructure can definitely be a hindrance to the adoption of machine learning methods, mainly because they lack scalability, on-demand availability, and can be expensive to deploy a machine learning model in an aging infrastructure. We often expect our banks to be on the cutting edge of things to be able to support our needs. There's obviously a transition period and investment that has to happen. What we see is there's really a need for technology modernization across not just small business lenders, but probably banks within the U.S. in general, to bring them more into the modern age of big data, cloud, scalable, distributed processing, things like that. That leads me to the next example, where we've talked a little bit. I mentioned legacy technology can impede machine learning. Mainframes, traditional data warehouses, obviously almost every bank is based off a mainframe or has been based off a mainframe type system in the past. Often there'll be an enterprise data warehouse or some type of data warehouse setup involved. Legacy systems and processes will often be adapted through the easiest point of integration versus the most optimal point of integration. So those can all be issues when you're trying to deploy advanced techniques like machine learning based models that require intensive compute, distributed processing, all these different things. So it's a great opportunity for a modernization effort. Now, those modernization efforts can be large and cumbersome, but we see the opportunity to go to a big data environment, distributed processing, parallel processing, on-demand and batch support both, as well as real-time capabilities. Obviously, we all want to have that decision today to be able to serve our client and give it to them in a scalable fashion for even large batch processes. So that leads you to the next step, to really say to partner or not to partner. This is an example of a small business lender with, say, $10 billion plus in assets, dollars in assets. The time to modernize your technology platform might be a 2 to 3 year cycle. Maybe it's already occurred, maybe it's yet to occur. Definitely a large effort, though, to modernize your technology platform. The time to develop a machine learning based model, we estimate to be probably a 6 to 12 month period. Obviously, you may be able to speed that up through throwing more folks at it. I do see in a space where you need to be able to make things as explainable as possible. That process takes a little bit more time. Definitely auto ML or auto machine learning methods aren't going to be great champion builders. You might be able to build some quick challenger models, machine learning based models, but it's made difficult to build that champion model from that without having someone in there to fine tune and really add that creative level to make sure we're getting the best output in the end. Time to deploy a machine learning model could take anywhere from 3 to 6 months, depending on the recoding that's required to deploy. You're also going to take time to gain your model risk management approvals as well. I see at large banks and even smaller banks, it's anywhere from probably a 6 to 12 month process. At some of the larger institutions I've worked with in the past, I've seen that can take 18 to 24 months or more, depending on the number of issues that get raised up during the model validation process. So in the end, really, this looks like it could end up being a 3 to 6 year process, depending where you are as a small business lender to support all these different areas. This would be going the route without a partner. Now, the same exact situation working with a partner, there may be an opportunity to look at an evaluation of a partner-supplied machine learning-based model. That validation might take anywhere from a 2, 3, 4 month period. That's pretty traditional from what I've seen, depending on how long it takes to get data ingested and all those type of things. And then the model risk management review process is probably going to be a 3 to 6 month period. That's what we've seen traditionally here with the clients that we work with our machine learning-based models. We've already done a lot of the pre-documentation to make it much easier to go through and complete the required documentation and speed up some of that validation process. So we see the opportunity to work with a partner can really reduce your time frame from down to 6 to 9 months. Definitely a large savings there, opportunity to realize value much quicker and much more efficiently this way. So just a summary of some of the key takeaways. Not all machine learning methods are created equal. Tree-based methods could be explainable to achieve regulatory compliance. As I mentioned before, really you can deconstruct them, you can enforce monotonicity, you can make them available for explanatory purposes as much as possible, explain the inputs, the outputs, and even explain what's going on within the middle compared to some other techniques, which may be difficult to break open some of the black box. Tree-based methods really have very minimal, if at all, any black box approach. Modernization, another area, key takeaway for today. Aging technology infrastructures need to be upgraded. I think that's across not just in the small business lending space, but across all financial institutions. There really needs to be a modernization that takes place to remain competitive, to make sure you can serve your customer at the moment when they need to be helped, they're taken care of and made an offer or made a decision on. And sometimes that can be difficult. That's where partnership may be your easiest route to quick adoption and value realization or maximization. Sometimes that time to market, if you can shave anywhere from 2 to 4 years, 5 years off that process, that may be a quicker opportunity to achieve significant business results. As I mentioned before, we're seeing where from a 6.5 to 10% to 15% lift in some of our machine learning-based methods. We also see a great opportunity to work with individual clients where we've seen some of the lifts in the 30 to 40% range for individual validations. That's definitely a huge improvement, huge change, whether you're trying to reduce losses, maximize profitability, reduce the risk of your overall portfolio, improve your internal optimizations, all those different areas. Well, that's all I had for you today. Thank you for spending your break with me. Hopefully I was able to help you better understand machine learning methods that are best for small business lending. Also, how to enable the deployment of machine learning methods, and that sometimes finding a trusted partner might make your journey even easier. If you have any questions or want to learn more about what I talked about today, feel free to use the link you see here. Also, if you want to get notified of future sessions, make sure you join the list. Now back to work, and good luck with your machine learning development and deployment.